We have an IC engine. There. So if you involve maybe part ignition or fuel. There. So we have part ignition. There. What is the name of this one? This one. This one. This one. How engine works? You have any idea how it works? Fuel, air, then compression takes place, then power. So, first initially, what is the input to the fluid? What is the input to the? So, for combustion, we need three parameters. That is fuel, oxygen, methane. Got it? So, the amount of heat given to the fluid. How much heat supplied? How much heat supplied? Either sometimes people call HIP, heat input, or sometimes people use present input. So, how to find out the heat given to the system or heat supplied to the system? So, we have fuel, and we know what is the calorific value of fuel. What is the calorific value? Unit of energy produced with kg of. For example, if a morning switch off, how much energy will release? How much energy will release? Okay, the kg is your U as equal to mass of fuel into calorific. If mass is kg, the yield will be If mass is kg per second, the yield will be kilojoule per second. Nothing but kilowatt. That is heat supplied to the system. Total amount of heat. How power is produced? Due to what? Combustion. Due to combustion, the power will be produced inside the cylinder. To make the power produce fuel or will produce fuel, right? Due to burning the fuel. That is called indicated. What we call indicated the power produced inside cylinder by burning the fuel. That's a simple definition of the indicator. We can easily find out what is our indicated power. The mark of the second formula we call plant. P-L-A-N. Plant. P is indicated mean effective pressure. L is length of the stroke. A is cross-sectional area. N is number of power stroke. If it is 4 stroke engine, then N by 2. So why N by 2? In 4 stroke engine, how many revolutions? 2 revolutions. It is given 2 revolutions, 1 power stroke. 2 revolutions, 1 power stroke. 2 stroke engine, 2 revolutions. 1 revolution. 1 revolution, 1 power stroke. Only for 4 stroke we use this one. For 2 stroke we use that one. It means rod is equal to capital V speed divided by U. Here small is equal to capital. Correct. K is number of cylinders. is about indicator. Okay, means I'm telling again is a heat given to the system is total fuel. Total fuel. This is power produced from the combustion of fuel. Only fuel. Got it? Only the fuel. This means the entire heat will not be produced. How much power is produced here? You see, for example, USP 1000 kilojoule. Your IP 1000 kilojoule, no, not possible. Some fuel may keep in cylinder. Some fuel may not be participate in combustion. So many will that is called indicated thermal efficiency. We call it efficiency. How much fuel is produced of power? How much fuel is produced? That is called indicated thermal efficiency. Indicated thermal. That is efficiency of indicated thermal. Nothing but what is the power produced by how much? How much? If both are same, 100%. When you will see 100%. But definitely it will not be 100%. If it is 700 kilojoule, if it is 1000 kilojoule, how much will it say? 70%. How much? 70%. Okay. Okay. So we are now applying only heat power and heating. The next one, input is over. Input is over. What is the output here? What is the output? Power is the output. Power is the output. Where do we get the power? From the where we take power from the engine? From the crankshaft. From the crankshaft. So this power is called brake power. This power is called brake power. The power is produced by the crankshaft. It's called brake power. Correct? So here we get the power. Here we get the power. Actually, in case here we get the power. Here we get the power. When it pushes the piston, this will rotate. It will be a shaft power. That power is called brake power. That is output power of the engine. That is output power of the engine. So now we see the brake power. For example, yes. Brake power. B. Okay, we can easily find out 2 pi intensity divided by 2 pi divided by 6. So it will be maybe watt or kilowatt based on the unit of torque. Based on the unit of torque. If torque is Newton meter, you will be watt. If torque unit is Newton meter, it will be kilowatt. Yes, it was here. Since speed is given in RPM, to convert in terms of RPS, we divide it into 6. Clear? For example, if torque is given because meter, but you need kilowatt, then put pound. Got it? Torque is given meter, but you need kilowatt. You need kilowatt. Go for divided by 1000. This is one formula is to find out what is the brake power of the engine. This torque also sometimes the torque cannot be given directly. They will be giving what is the net load acting on the shaft. What is the net load acting on the shaft? What is the radius of the drum? They will give a both. You can find out C is equal to W into R. If W is net load acting on the drum, it is the Next one, brake mean effective pressure. I already informed right what is mean by mean effective pressure. No, right? Yes, sir. I informed okay what is mean pressure. Example, during the power stroke, piston moves from EDC to BDC. It will drop here. It will drop here. It will drop here. It will drop here. Do you think pressure will be same at all the points? No. Pressure will keep on reduces. Pressure will keep on reduces. But for calculation purpose, we don't go for the one. What we take, we find out what is the average pressure in the entire stroke, power stroke. Average pressure of entire. We take each point we have it. We take average. The average pressure during power stroke is called mean effective pressure. The average pressure during power stroke is called mean effective pressure. Here, sometimes we get mean pressure we can find out what is our indicated power. We get here we get what is our brake power. Means lowest H value. Lowest H value. Okay. So if this one find out what is our brake power. Now you think your indicated power, brake power are same. You think our indicated power here this power and this power is same? No. Why no? Why no? Frictional loss will be there. The movement of the piston is there. The movement of the piston is there. Here also we have piston, and there is a number of losses will be there. Lot of things will be there, right? So some losses will be there. Those losses will be frictional losses. What say? I write here. Frictional loss. That is, we will take loss or power. We take frictional power of the brake. Fp is equal to what is the mean power minus what is over brake power. Brake power. If frictional loss is there, what efficiency we find out? And we talk about friction. What type of efficiency I have to go? Mechanical efficiency. Mechanical efficiency we have to go. We have to go for mechanical efficiency. Mechanical efficiency is equal to what is your output, what is your dV by IP. If both are same, we get again 100%. Let us be under higher mechanical efficiency, higher the engine performance. Lower mechanical efficiency, lower the engine performance. Similarly, higher the mechanical efficiency, higher the heat produced by the combustion fuel. Lower the mechanical efficiency, lower the heat produced by the burning fuel. Correct? These are the major things here. So we completed mechanical efficiency. Correct? Correct. Then I cannot see only mechanical efficiency. I want one more efficiency called my input and brake power. My input and brake power. That's called brake thermal efficiency. What is called? Brake thermal efficiency. Brake thermal efficiency. What is our output? Brake power is our output. What is our input? It is our input. It is our input. This is called brake thermal efficiency. Correct? Correct. So we have three brake thermal, mechanical, indicated efficiency. We have three power, indicated power, brake power, and friction power. Correct? Three power, three efficiency. This is performance. What is called performance. If people ask what is your relative efficiency, what is relative efficiency? That's nothing but what is the right efficiency divided by actual efficiency. If you want to go for actual efficiency, relative efficiency into ideal efficiency give actual efficiency. You know always this formula. Okay? If you want to know what is actual efficiency, that is what the ideal efficiency divided by the relative efficiency, ideal divided by actual. If you want what is your actual, that is nothing but relative efficiency into ideal efficiency give your actual efficiency. Third efficiency, that will be your. Correct? Then this is a summary. What about the heat loss? What about heat loss? We have heat loss also, right? We have heat loss. Correct? So, for example, we go for input output. This is our input. This is our output. No changes. No changes. In between, we water. Right? Nothing but QCW equal to MCW CPCW. Temperature of cooling water minus temperature of cooling water. This will give amount of heat loss due to cooling water. What you need to put in the motion. Clear? This is what we have. Then we will do reaction, right? Because due to exhaust gas. We have exhaust gas, right? That's also we can consider nothing but because due to this place, and this place, QEG. This is QCW. Right? Then we have QEG and QCW. Because due to exhaust. Same thing we can find out QEG because gas nothing but mg and CPG PG minus PG. This mg is mass of exhaust gas. Sometimes question will be given mass of the exhaust gas. Sometimes they won't give. They give mass of fuel is mass of air. You know, whatever mass in the system will you in that, right? Whatever mass in the system, in the system. So we will also adjust air also. Both will adjust. So both from the system. So this mg is nothing but sometimes m1 plus mg. Correct. So if the given question comes, you have to take. You should not take only m1. You have to take only m1. Correct. This is nothing but this exhaust gas temperature. But it is into the temperature. What is temperature? Atmospheric temperature. Okay, that's why I put the atmospheric temperature. Correct? Read out. So, other than these two losses, we have unaccounted losses. What is that? Unaccounted losses. These unaccounted losses due to fuel escape from the engine. The fuel is not present in the combustion. Today, due to radiation, important one, due to radiation, these losses will not be calculated. So, what we do, we will take what is our input, we minus it, we go all losses, nothing but Q unaccounted is equal to 2s, that's our input, minus, we add all those things. Heat loss due to brake power. Brake power is not a heat loss. So, brake power is not a loss. Brake power is not a loss, but we have to count for the heat loss calculation. The useful power. Okay? Useful power. You want to say useful power, you will take one of the loss to calculate the heat loss. Calculate the heat loss. So, brake power. So, heat loss is brake power. Number 1. Plus heat loss due to cooling water. And 3. Heat loss due to exhaust gas. Correct? If you minus all these three, you get what is work minus. Okay? What is work? Unaccounted loss. Correct? So we have no heat loss. 1, 2, 3 heat loss. 4th one unaccounted loss. You have to calculate what is the percentage of heat loss. The percentage of heat loss due to brake power. First one due to brake power. Nothing but what is the heat loss for brake power? How much heat is given? How much heat is supplied? This one, the percentage of water, cooling water. That is what is the heat loss due to cooling water? What is the amount of heat supplied? Third one, what is the percentage of heat loss due to exhaust gas? Nothing but what is the heat loss due to exhaust gas by final one, what is the percentage of unaccounted losses? That is what is the percentage of heat? We calculate. This takes 60%, this takes 20%, this takes 15%, this takes 5%. We draw by that. Because we say from that this loss will be there due to brake power. This loss is there due to cooling water. This loss due to exhaust gas. This loss due to calculation the